Hello students, in this video we are discussing Cbse class 9 NCERT textbook science chapter 8 motion. So this is the first chapter for physics and we've already seen 7 parts of this lesson and now we are going to look into the 8th part of this lesson. Previously we just started with the graphical representation and I taught you certain concepts which are about slope and all. We learnt what is slope, what is negative slope and what is positive slope, okay, and what if there is no slope and all. So all these we learnt previously so that you would have got an idea about this graphical representation, okay. When you want to represent a motion graphically, we know there are a few main parameters. So what are they? We can calculate the distance, time, speed. Isn't it? These three are the main parameters. These three are the main parameters which we'll be seeing. So among these three parameters, we are taking speed to be, you can either call it as speed or if it is in a perfect particular direction, you call that to be velocity. We call that to be velocity. And we are always comparing both the distance and the speed or any parameter with time always. Our parameter of comparison is always time when we talk about motion. When you say you are going slow, you are relating it with time. When you say you are going fast, you are relating with time. Okay. So however you talk about motion, you are going to relate it with time. So time is the basic parameter. Now the time is compared with what? How long you travel and with what speed you are going to travel. How long talks about your distance and with what speed. If it is a particular direction, you talk about the velocity. Okay, so time is plotted along the x-axis while distance or velocity is plotted along the y-axis. So our graph is always in this way. So if you talk about the y-axis, it will always be either distance or velocity or you can say you have even speed. Sometimes if the question says about speed time graph, it is speed and time. Sometimes it's given as velocity time graph. Always in the x-axis what do you have? X-axis it is always time by default. Okay, so in your x-axis you will have time and this will be in your y-axis for distance time graph. For velocity time graph, it is time on the x-axis and velocity on the y-axis. So these are the two basic graphical representation of motion. So distance time graph. So in distance time graph, what will be there on the y-axis? In the y-axis, you will have the distance. The y-axis, you will have the distance, and in the x-axis, you will have the time. So this is what we are seeing, and we are going to discuss about distance time graph. See here, you can see how the graph keeps on changing. See, it's increasing. See, here you can see it is a positive slope. It is a positive slope. But if you see in this, you can see that it is continuously, it is changing. It's increasing, then it is straight, maybe there's no slope, and then it can increase again no slope. So like this it can change. Okay, so that is what we are going to see, under what type of motion it might increase or it is stable and all. Okay, so the first case is for stationary object. So here you are going to see two places. Okay, so this place depicts a school. This is a building of a school, and this is the building of a house you can take. Okay, is your house and your school going to keep moving? No, under any condition it will not move. If at all it moves, then it means that there is some problem in the environment, or there is some natural calamity, there is some earthquake, or there is some disaster. Only then you can see that there might be a movement, or else it will never move. Our house is also at rest and the school is also at rest. Okay, now if you want to calculate the distance between the school and the house. Okay, if you want to calculate the distance between the school and the house, morning 8 o'clock if you are going to calculate, if it is going to be at a distance of 10 kilometer, you know that whatever time you calculate, 8, 9, 10, or even if you are going to calculate at midnight 1 a.m. if you are going to calculate early in the morning also, the distance will be the same. You can see that the distance will remain the same at any point of time when the objects are going to be stationary. So the objects are going to be stationary, it will remain the same. The distance between the two objects will be the same. So when you are going to plot a graph in this way, you can see that the graph is a straight line parallel to the time axis. This is the time axis. Parallel to the time axis. What did we already learn? If you have a graph parallel to the time axis, then do you have slope? No, there is no slope. The slope is going to be 0. That is what you are seeing here. The slope of the graph is 0. Okay ma'am, why do we need to do all this? Why you need to find slope when there is nothing? Now when you will learn it when we learn about the next case. So this is the case for objects at rest. Now, what if an object is moving at uniform speed? What do you mean by uniform speed? Uniform speed means it is going to cover equal distances in equal intervals of time. Okay, that is, if it is going to cover 5 kilometer in the first 1 hour. Okay, if I am going to say it is going to cover 5 kilometer in 1 hour, அப்ப என்ன ஆகும்? In the second hour it will cover an extra 5 kilometer only. Same distance only it is going to travel. Second hour again 5 kilometer. Third hour again 5 kilometer. So the distance covered is going to remain the same throughout. Okay, that is what we are seeing here. Distance is going to remain the same throughout. So that is what we are able to observe here in this uniform speed. Okay, so this graph, when you are going to plot, how will you get the values? See here, if you are going to have the time to be first 1 hour. 1 hour it is traveling 5 kilometer. So let me take this value is going to be 5. Second hour another 5. Up it will be 10. Third hour another 5. It will be 15. So the next 20. So you can see that it is traveling equal distances. 5 hours in every 5 kilometer in every 1 hour. Okay. So when you are going to have a graph, you can see that the graph is a straight line inclined with the time axis. How is the graph? Your graph is a straight line inclined with the time axis. Okay. Now you know how to find the value of the slope. What is the value of the slope? The value of the slope is what? We already know, change in y coordinate by x coordinate, or as I told you, you can have it either as rise by run also. Okay, so this is the value of the slope. So now what is there in the rise? Check carefully what is there in the rise. Rise is this. Rise talks about the distance traveled. That is why we are writing rise here. Okay. So instead of your rise, you are going to mention the distance. Likewise, instead of run, you are going to mention the time. So what is my slope here? My slope here is distance by time. What is the formula for distance by time? We know that it is going to be the speed. It is going to be the speed. Now with this I can say that by looking at the slope of the graph, I can calculate the speed of the object. I can calculate the speed of the object. So my slope will give me the speed of the object. That is why when the objects were at rest in the previous case, we could see that the slope was 0. When will the slope be 0? When there is no speed at all. Okay, if there is no speed, it means that the object is at rest. That is why we got 0 slope in the previous case. So the slope of a dt graph gives the speed of the object. Slope of a dt graph gives the speed of the object. This you will have to remember. Whenever you remember dt graph, you should remember the concept that the slope will give you the speed. So for any case, it is going to give you the speed. The speed is going to be 0, or the speed is going to be 0 means it is going to be at rest. Otherwise, we will always say the speed cannot be 0 or negative. That is, the velocity is 0. Okay, so all these will be saying. The next is for non-uniform motion. Uniform motion is when you have equal distances in equal intervals of time. Now, non-uniform motion. So what is this non-uniform motion all about? So when you say non-uniform motion, uniform motion it is going to be equal. Non-uniform motion it is going to be unequal distances in equal intervals of time. Adilla you will have two cases. One is called you go either fast or you go slow. You either go fast or you go slow. Fast means what? You cover more distances. You cover more distance. Slow means what? You cover less distance. Slow means you are going to cover less distance in the same given amount of time. So now we will see the graph for the non-uniform motion. See, accelerated. We know what is accelerated. Accelerated means going fast, or you can say it is the speeding up. Okay. So here you can see that the slope of the graph is increasing with time. Slope, what is happening to the slope? It is increasing. See, the value will slowly keep on increasing, because the distance traveled is what? Going to be higher and higher as time goes, because we are going to travel greater distances. Okay. So the slope, again this is the same thing. The slope will give you the speed. Okay, there we had a straight line, so it was easy to calculate. Now it is going to be a curved line. So when you have a curved line and when you are going to find out the slope, what you will do is, they will be asking you between a particular time. They will say between 5 and 6 hours what is there. You will have to drop down the lines like this, and then you will calculate this as the rise and this as the run. Again, what is rise? Rise is nothing but the distance. What is run? Run is again the time. So distance by time will give us the speed. So we can say that the slope will give the speed of the object. Similarly for slowing down also. So what is there for slowing down? You can see that the distance traveled, though it may appear to be increasing in the beginning, it will slowly start decreasing. So slope of the graph is decreasing with time. For accelerated motion, how did we have the graph? We had the graph to be like this for accelerated, and this is for decelerated. Okay, so decelerated. So again here the slope will give the speed. So how we will calculate here? Here also if you are going to calculate between two timings, so you will have to drop the value here. Again this one, so you will join to the x-axis also. So this will give you your rise and this will be your run. So my slope will be what? Rise by run. So what is rise by run here? It is distance by time. What is distance by time? It is nothing but the speed. So my slope will give the speed of the object. So these are the different cases for distance time graph. See here you can see how the graph is going to keep changing. Here you can say it is going to be uniform motion, but it is increasing. Okay, here it is at rest. When the slope is not there, it is at rest. Here it is returning back. It means what? The distance, it might increase, but if it goes down, you can say that here it might talk about the displacement and all. Okay, that you will learn when we learn about the problems. A little more when we go into the numericals, you can see these are just sample graphs. So with this you can calculate how much time is taken. See this graph, see, you can calculate the speed. So if you want to calculate from 0 to 10, you can calculate the speed. Likewise, from 10 to 40. 10 to 40 means what? This and this. Isn't it? Yes. So again, Here it is going to be at rest. Here again it is going to be at rest. So this it is going to keep decreasing. So here also you can calculate. So somewhere between 44 I think. Okay. So 44 and 54. So like that you can calculate. You have some numericals. We will also do some after we complete even the velocity time graph also. So first we have completed distance time graph here. Okay, so with this we have learnt about the distance time graph. So distance time graph, we saw three cases. What are the three cases? So broader we had two cases. So first one was for uniform motion. Sorry, the first one was stationary. Okay, so we had stationary objects, or you can say the object is at rest. Second one is for uniform motion, and the third one is for non-uniform motion. Okay, under non-uniform motion you had two cases. For stationary you had a straight line parallel to the time axis. For uniform motion you had a increasing slope. For non-uniform motion it was either increasing or it was decreasing. Okay, so all these three gave us the speed. How? By calculating the slope. The slope gave us the speed. Only here the slope is 0 because the object is at rest. Hope you understood these concepts. If you have any doubts, please get back to the video again and try to understand. If you have any doubts in understanding uniform motion, non-uniform motion, what is speed, distance, time and all, please get back to the older videos which are there in the playlist also, so that you will be able to understand. Okay, see you again in another video, children. Thank you, children.